Welcome to all my dear students. This class will see about electrolytes used in replacement therapy. So, under normal physiological condition, the body mechanism are able to adjust the electrolyte balance and no replacement becomes necessary. So, in various conditions such as prolonged fever, severe vomiting or diarrhea, there occurs heavy loss of water and electrolyte. In that cases, so we have to give them electrolyte replacement therapy. So in various condition, what are all the condition? Prolonged fever or severe vomiting or diarrhea. So there occurs heavy loss of water and electrolytes. So in order to compensate this, administration of lost electrolytes in appropriate concentration of toxicity becomes essential. So however, there are two types of solution of electrolytes which are used in electrolyte replacement therapy. There are two types of electrolytes. That means a solution for subsequent replacement and second one a solution for rapid initial replacement. There are two types of electrolyte to be used for electrolyte replacement therapy. A solution, first one, a solution for rapid replacement therapy. So this is mainly similar to that of extracellular body fluid present in our body. So these combination especially similar to that of electrolyte extracellular body fluid. So this solution is having sodium, calcium, chloride, potassium and magnesium and bicarbonate. They are having this composition like sodium 130 to 150 milli equivalent per liter, chloride 98 to 110 milli equivalent per liter and bicarbonate 28 to 55 milli equivalent per liter, like potassium 4 to 12 milli equivalent per liter, calcium 3 to 5 and magnesium 3 milli equivalent per liter. So these composition especially similar to that of extracellular body fluids. And next we'll see about the solution for subsequent replacement. What is that? A solution for subsequent replacement. This has combination of like composition of this also constituent sodium, chloride, bicarbonate, potassium, calcium, magnesium and phosphorus, like cationic and anionic electrolytes are the composition of solution for subsequent replacement, and these are also having this much composition like sodium 40 to 120 and chloride 30 to 105 milli equivalent per liter and bicarbonate 16 to 53 and potassium 16 to 53 and calcium 10 to 13 milli equivalent and magnesium 3 to 6 milli equivalent and phosphorus 0 to 3 milli equivalent per liter. Okay, so there are some electrolytes that are used in replacement therapy. So what are all the electrolytes here? So according to your syllabus, sodium chloride, potassium chloride and calcium gluconate. So sodium and other formulation also, that sodium chloride and its salts such as sodium chloride and other formulation, sodium chloride and sodium chloride injection, it is nothing but hypertonic solution saline, and sodium chloride in the form of tablet and sodium chloride mixed with dextrose injection and mannitol and sodium chloride injection. USP method also available, sodium chloride and their formulation. Likewise potassium chloride and its other formulation like potassium chloride, potassium chloride along with glucose IV infusion. Next, so mixture of sodium chloride and potassium chloride IV injection. Another method, potassium chloride, sodium chloride and glucose IV infusion. So next, replacement by calcium or calcium formulation, calcium in the form of calcium gluconate injection. There are the different types of formulations are available, and calcium gluconate tablet and calcium lactate and calcium lactate injection and tablet, and levolunate and calcium levolunate injection, and calcium pentothenate and calcium dibasic phosphate, calcium phosphate tribasic IP and BP method, and calcium sodium lactate, so the BP method. So these are the different types of electrolytes, as in the form of sodium chloride and its formulation, and potassium chloride and its formulation, and calcium gluconate and their formulations. Now we will see elaborate manner about sodium chloride. So everyone known about sodium chloride is nothing but table salt or common salt. So what is the molecular weight here? Molecular formula NaCl, and molecular weight 58.45 gram, 58 mole, 58.45. So it is having not less than, suppose if we dried at 130 degrees Celsius, the substance should not more than 99% and not less than 99% and not more than 100.5% of sodium chloride with reference to the substances. So it contains no added substance. And then how can we prepare? So it is normally how we are preparing from industrially and the laboratory. There are two methods are there. In the laboratory, the common salt, that means impure salt in water by passing hydrochloric acid. So the crystals are precipitated out. Second method, by industrially, it is prepared by sea water deposits and for the purification by purified rock salts. Then properties, so everyone known about for why, because in our day life we are using salt, sodium chloride or common salt. So it is a white crystalline powder, odorless, soluble in water, glycerol, and slightly soluble in alcohol. Characteristic, because of chlorine present in that sodium chloride, so it oxidizes and it can liberate the chlorine gas. So this is a example for the substance liberate the chlorine. So this is the chemical equation. Under oxidation, it liberates the oxygen. Okay, so with silver nitrate, one more test with the characteristic with silver nitrate solution. So it is gives the precipitate, insoluble precipitate of silver chloride and sodium nitrate. These are the characteristic of sodium chloride. And next we'll see about identification. It gives characteristic of sodium and chloride test. Then we'll see about test for purity. So there are the tests to be conducted for acidity and alkalinity, arsenic, barium, calcium, magnesium, iron, heavy metals, and iodides and sulfate, and loss on drying. If we go for the loss on drying, the substance should not more than 1% at 130 degrees Celsius. This is the limit to the sodium chloride substances. Now we'll see about how can we perform the acidity or alkalinity of the substance. So 5 gram, that means 5 gram of the sodium chloride dissolved in carbon dioxide free water. So how can we prepare the carbon dioxide free water? It's nothing but let the water boil it and cool that. So during boiling, so it liberate the oxygen or carbon dioxide present in the water. So thereafter it is eligible to use for carbon dioxide free water. That is nothing but carbon dioxide free from water. So and then it is titrated with sodium hydroxide. For alkalinity you have to titrate with sodium hydroxide, and for alkalinity acidity we may titrate with a hydrochloric acid using phenol red as an indicator. So that during that titration time, so the consumption of volume of either sodium hydroxide or potassium hydrochloric acid should not more than 0.5 ml of 0.0, that means n by 100 sodium hydroxide strength or n by 100 hydrochloric acid. Okay, so next, this is the test for purity of alkalinity and acidity. And next one, calcium and magnesium in a conical flask. So you take a conical flask with the add substance, that means 20 gram in 200 ml of water, and 0.1 to this add 0.1 ml of hydrochloric acid and 5 ml of strong ammonium chloride solution. Then it is to be titrated with 5 drops of erichrome black tea using EDTA, ethylene diamine tetraacetic acid, strength of 0.005 N. So what is the N point become blue color. So each ml of 0.00 each ml of 0.005 m EDTA is equivalent to 0.00020004 gram of calcium. This should not more than 0.05% of calcium. So similarly it can be calculated for magnesium also. This is the test for purity for calcium and magnesium. Next, for barium, it's nothing but 2 gram of the substance or sodium chloride dissolved in 10 ml and add 2 ml of hydrosulfuric acid. No turbidity. It is analyzed by Olgart's method. So it is analyzed or assayed by Olgart's method. So the assay of how to do the assay, it is assayed by Olgart's method. And also we may discuss about modified, how they are performing modified Olgart's method. So point 1, it is very important, Olgart's method. So sodium chloride, what is the assayed by, what is the assay method for sodium chloride means you should write about Olgart's method. And how do you perform or analyze it by Olgart's method? 0.1 gram of the substance dissolved in 50 ml of water. It is to be taken in a stoppered flask, glass stoppered flask, and add 50 ml of 0.1 N silver nitrate and nitric acid and 5 ml of nitrobenzene and 2 ml of ferric ammonium sulfate. FAS nothing but ferric ammonium sulfate, and it is to be titrated and shaken well. Then ammonium thiocyanate becomes reddish yellow. So this is assayed by Olgart's method. Each ml of 0.1 N silver nitrate is equivalent to 0.005844 gram of sodium chloride. Then how can we perform Olgart's precipitation method with modification? Here is nothing but without adding of nitrobenzene. Because of this, avoiding nitrobenzene prevent the interaction of silver chloride with a ferric ammonium sulfate. Okay, so that this is the simple modification from Olgart's method. Next, dosage form. The solution available in form of solution, tablet and parenteral solution. Storage, it is to be stored in airtight well closed container. And uses of sodium chloride, there are lot of uses of sodium chloride. First one, it is the sources of sodium and chloride ion. Major uses, sources of sodium and chloride ion. Then 0.9% weight by volume solution is isotonic and is used as wet dressing and irrigating body cavities or tissues. Next, electrolyte replenisher. Fourth one, hypertonic solution. Used, I already told you, synonym of sodium chloride is nothing but hypertonic solution. It is used in condition during excess loss of sodium along with water. Then it is to be given orally. It induces vomiting in case of poisoning as a first aid. It is a constituent of Ringer's solution, Ringer's injection, lactated Ringer's injection. Next, the sodium chloride, potassium chloride, IV infusion and ORS. That is, it is the one of the constituent for the combination therapy of like oral rehydration salt ORS and Ringer's solution, etc. Thank you.